Molecular geometry is just a really fancy way of saying what shape each of these molecules have. The only way that you can determine the shape of the molecule is after having drawn a Lewis dot structure. A Lewis dot structure gives us really valuable information, such as what type of bonds exist between the atoms, how many lone pairs there are, and that dramatically affects the overall molecular shape. So the first thing that we're going to need to do is to count the number of areas of electron density. And there are two things that count toward electron density. One, bonds count as areas of electron density. And the weird thing is that both double and triple bonds count as one bonding site. So they only count in as like a total of one. And then the next thing you're going to want to do is to count your lone pairs as well, as they count for an area of electron density. Now what we're going to be following here is something called VSEPR theory, or valence shell electron pair repulsion. And the idea is that electrons, because they have like charge, will repel each other. So if they're going to be near each other around a central atom, then they're going to push each other away until they're as far away from each other in space. Now that includes bonds and lone pairs. So bonds actually repel, as do lone pairs. So let's just say our Lewis dot structure says that we're going to have one bond but no lone pairs, or two bonds with no lone pairs. Essentially, what that would allow us to do then is to separate the bonds available as far apart from each other in 3D space. That would be about 180 degrees. Both structures here look like tiny little lines that would actually indicate a kind of a geometry called linear. So again, if you take a look at the atoms and how they're lining up, we call that linear. Well, next up is going to be three bonds, or three areas of density. The shape is called trigonal planar. So if you can imagine arranging these three areas of electron density as far apart in 3D space as you can, that would be basically 120 degrees apart. And if you look at the bonds that are present, it's going to determine the name of the shape. So if you can actually see all three bonds because you have three atoms around the center nucleus, then that's going to be called trigonal planar. Replace one of the atoms with a lone pair, you're really only going to be focusing on the atoms when you go to name the shape. And it's going to look linear, that just somehow got bent out of shape. That lone pair pushes the two bonds away from each other, away from that perfect 180 degree distribution, and bends that line, so we call it bent. Well, take another atom off and replace it with another lone pair, and realistically you're just looking at two atoms connected in space, so we call that shape linear. Let's bump it up a notch here. Let's go to four areas of electron density. The base shape is called tetrahedral. So if you could actually separate out these four atoms in 3D space around the central nucleus, they would actually be about 109.5 degrees apart. And it actually kind of looks like a jack, a little bit. You can see that it kind of has like a triangular shaped area on the bottom. It's like a pyramid, and then like a flag up to the top. That would be called tetrahedral when you have four bonds and no lone pairs. Well, what happens if you need to replace one of those bonds with a lone pair? Well, all you'd be able to see is that triangular shaped pyramid on the bottom. So we call the shape trigonal pyramidal, based upon the atoms that we can actually see. Replace another bond with a lone pair, and what you're going to be down to is again that weird bent shape. And that bent shape is literally called bent. And the bond angle here is kind of funny. The lone pairs are really good at repelling other electrons because there's not a lot of mass behind it. It can actually push a little harder. So it actually squeezes down that bond angle to about 105 degrees. Now if you can imagine taking that last bond off and replacing it with one more lone pair, what you'd be left with is two atoms bonded in 3D space, three lone pairs around the back atom. It would still be considered to be linear. Let's add in another area of electron density, bringing our total up to 5. The base shape is called trigonal bipyramidal. And if you could imagine trying to distribute 5 things in 3D space equally, what you'd actually end up with is 3 spinning around like a center axis, and they'd be about 120 degrees apart. So there'd be a triangle shape on the inside. And then if you could imagine hanging a flag up and putting a flag down, they'd be about 180 degrees apart from each other. That would be basically your trigonal bipyramidal shape. So if you can imagine taking one of those bonds off and replacing it with a lone pair, the shape that results is called seesaw. Take another bond off, you'd be left with something called T-shaped, and yet another bond off, and you go back to being linear. Final shape, very, very interesting. It's based off of 8 areas of electron density, and the base shape is called octahedral. Octahedral actually looks like a jack. There's 4 around the center, 1 up and 1 down. Everything is exactly 90 degrees apart. Very, very symmetrical. If we replace one of the bonds with a lone pair, it goes to something called square pyramidal. Another bond with a lone pair, square planar. All 4 are around the center axis in a square type shape. Another one, go down to 3 bonds, 3 lone pairs. That's called T-shaped. Replace 1 extra bond with one of those extra lone pairs, and it goes back to being linear. So it's kind of interesting if you kind of actually take a look at the molecular geometry. Again, it's something you kind of just need to know the names for and be familiar with the shapes, and then just kind of match it up with your Lewis dot structure afterwards. Most everything is based off of the tetrahedral shape. Most everything. The last 2 shapes, the octahedral and the trigonal bipyramidal, are really more specialty shapes. They're used very seldomly. So you're probably safe if you kind of make sure that you know everything up to and including tetrahedral.